Go. So I'm recording. Okay. Okay, so last time we did start factor by grouping. I did write out the procedure for it, and I figured now it would be good, to complete a bunch of examples, okay? So I figured now it'd be good to do that. Let me just make sure. All right, cool. Okay. All right. Okay. And again, this technique is really what you want to use when you have four terms, as you do here, right? The notes are posted on Blackboard under week 3 in the content folder also. But again, when you have 4 terms like this, you want to make sure you really want to try factor by grouping. In fact, the next factoring technique we'll learn, you convert a polynomial of degree 2 with 3 terms into a polynomial with 4 terms, and you will apply factor by grouping. So anyway, what I want to do is do more examples of this. Okay, so here's our polynomial. Now, usually you really want to get the greatest common monomial factor, the GCF. You really want to try and get that out first if you can. Just makes it a little bit easier. And that's what we have here. So there is a non-zero constant term, right? Which basically means, yeah, we take our m to be 0. But really, it just means, though, that more precisely, you can't factor out an x from the entire polynomial. You can't. Because there's a term with no x's, there's nothing here to take out. So we can take m to be 0. But notice that 2 itself is a factor of itself and of 4 and 8. So 2 is a factor of itself, 4 and 8. In other words, if you were to list the factors of 2, 4, and 8, you would see that the greatest common factor of 2, 4, and 8 is 2. So our GCF is just going to be 2. Okay, that's fun. Does that help us? Well, yeah, we have a GCF. We can factor it out. And that's what I'm doing here. Remember, when you factor it out, excuse me, what you want to do is you put that factor in front. And what you want to do is you divide to see what's left over. And when you divide into a sum or difference, you have to divide into each term, as I'm doing here. So we divide into each term. And doing so, what ends up happening is, as you'll see down here, you end up with, here, let me see if I can get the pen. So here, as you can see, these 2's are going to cancel. Here, this 2 is gone. This 4 becomes a 2. Oh, what am I doing? Was that eraser? Here we go. There we go. All right. So this 4 up here becomes a 2. This 4 also, right, this cancellation, this becomes a 2 as well. And 8 over 2 becomes 4. So in other words, we're going to get this. And that's what we end up getting. Now, we're not done yet, of course. We just factored out the GCF. Okay, so we have to see. We have to now factor by grouping, because now we have to factor what's in the parentheses here. So remember, the first thing you want to do is what you want to do first is you're going to form 2 groups of 2. Namely, the first 2 terms you put in a group. That's what the parentheses tell us. And the second 2 terms, the third and fourth term, you're going to put that into a group as well, like so. Okay? Okay, so now we have to handle each of these groups individually. That's what I'm going to start doing here. So basically what you want to do is factor each individual group. That's what we want to do. So for this one, we're going to factor it. Basically, we're going to factor out, we're going to find its GCF, and we're going to factor it out. Okay, what would it be? Well, notice that the smallest exponent of x is 2, right? As you can see here. Also, since we have a coefficient of 1, you really can't factor out any numbers. Or more precisely, the greatest common factor of the coefficients, 1 and 2, is just 1. The only factor of 1 is 1. So because of that, the only thing we really can factor out of this is x squared. In other words, its GCF is just x squared. The GCF of this thing is what I mean. Actually, you know what? That's fine. And because of that, we can only factor, let me just draw this and this might help. So from here, this GCF of this thing, okay, I think that I tried to draw an arrow. I don't think I was successful, but hopefully you can see this is what I mean. But now we're going to factor this thing. Namely, we're going to factor out its GCF. We're going to factor out x squared. In other words, we're just trying to factor out any common factors here, and that's what we're doing. So we put the x squared in front as before, but again, to see what's left over, this is what the division is for. We have to see what's left over. And as before, you're dividing into each term. Here we subtract exponents, right? 3 minus 2 is x to the first, x. The x squares cancel, we get this. And this is the first group, right? So we have x squared times x minus 2. Now we're going to do the same thing with the second group, 2x minus 4. Well, notice that we can't factor out an x, right? Because there's a constant term here. Excuse me, a non-zero constant term. In other words, the smallest exponent of x is 0. 2 and 4, though, their greatest common factor is 2. Hopefully, it's easy to see that. I mean, you can always list the factors if you want. Actually, you get that 2 is a factor of 4, so 2 itself has to be the greatest common factor of 2 and 4. So its GCF is 2. Let me draw another arrow for fun. Okay, maybe I'll get this arrow right, and oh, goodness gracious. Boy. I forget it. I think you know what I mean. All right. What? Yeah?
So for like honestly the past 15 minutes, your screen has been completely frozen.
Really?
Yeah, I sent it in the chat, but I don't think you saw it.
Oh, no, I didn't see it. Oh,
And
a bunch of people see it.
Yeah, one other person can't see it either.
Oh, no. Let me see. That is so weird. Oh, there it goes. I'm sorry. I can start. I'm sorry about that, everyone. So someone refreshed it. They can see now. Okay. Can everyone see it now? Yeah. Okay, someone else. Can people see it now?
And now I can see it.
Okay. So someone said they refreshed it. Let me and now they can see it. So okay, here. Let me just pause. Yeah, let me try sharing it again.